This is Algebra 2, Lesson 7.2, and we're going to focus on factored form today. So this is something we already wrote on the first lesson in the packet, but I'm going to put it on there again because that's our focus for this page. So we're not going to do a lot of graphing in this chapter, but the way that this factored form works is when you have a U-shaped parabola, the coordinates where that shape would cross the x-axis, those would be the roots that you would substitute into your format here. Now, we are going to look at going into factored format, which is exactly backwards from what we did on 7.1. So this first equation here starts in general form, and my goal is to put it into parentheses. So the reverse of last lesson. So that means we're going to start inside and work our way to the values on the outside. So I'm going to start with my three terms inside the box. And we're going to figure out what would be on the outside to make this happen. Now, I think it's really easy to start off with x and x, because the only way to get x squared is x times x. Anytime you have a leading coefficient of 1, it's going to just be x times x. Next, I like to look at this term right here, and I try to list the possible factors for 6. The reason being, we need two numbers here that are going to multiply to 6 and at the same time add up to 5. Now, the factors of 6 are a finite set. There's really only two ways to get to 6. You can do 1 times 6, or you can do 2 times 3. So I'm looking at a limited set of numbers. If I try to think of all the ways to add up to 5, you might think, well, there's not many. There's 0 and 5, and then there's 1 and 4, and then there's 2 and 3. But you could technically also say, well, what about 100 and negative 95? So there's really a lot of different ways to get to 5 through addition. But looking at just 1 and 6 and 2 and 3, if I try to add 1 and 6, that would give me 7. If I try to add 2 and 3, that will give me 5. So I'll have 2x and I'll have 3x. Doesn't really matter in this situation where the 2x goes versus where the 3x goes. But to get this number on the outside, I would say what times x gives me 3x, and that would be 3. What times x gives me 2x, and that would be 2. So x plus 2 was my set on the side, and then x plus 3 is my set on the top, stick a y equals in front, and that is my finished factored form from the original given general form. I'm going to slide this down a little bit, and we're going to do example B. Same thing, we're going to start with three terms down the diagonal, x squared, 3x, positive 10. In this case, it's really easy to just start with x and x, but now, I made a mistake. There's a negative here, so there should be a negative. There's a minus there, so there should be a negative. But anyway, we're going to start the same thing. We're going to say what are our factors of, in this case, negative 10. So I'm going to just pretend it's a positive 10. That's 1 and 10, 2 and 5, and that's the only ways to get our factors of 10. But because I have this negative here, I'm not going to say what plus what is 3. I'm going to say what minus what is 3. So I can either say 10 minus 1, which gives me 9, or I could say 1 minus 10, which gives me negative 9. Neither of those work. I could say 2 minus 5, which gives me negative 3, or 5 minus 2 gives me a positive 3. So that would be a 5x and a negative 2x. Again, it doesn't matter which one's the 5 and which one's the negative 2. But I'm going to pull the 5 out for this one, I'm going to pull the negative 2 out for this one, and I have my equation x plus 5 and x minus 2. So those were kind of straightforward. Now let's mix it up by adding a leading coefficient of not 1. I got a 2 in front of my x squared this time. So I have y equals 2x squared minus x minus 15. We're going to start with our three terms along the diagonal. 2x squared minus x minus 15. A lot of people like to make sure there's numbers there, so if it helps, you can add the negative 1 there, that invisible 1. But I can't start the same way. I can't just say x and x because there's this 2 here. So I can put a 2 here, or I could put a 2 here. It doesn't really matter. Just pick one. Now, I'm not going to do this either. I'm not going to say what is negative 15's factors. I'm actually going to do 2 times 15, what are negative 30's factors. Excuse me. And we technically did that every time, but when the leading coefficient was 1, 1 times 6 was still 6. 1 times negative 10 was still negative 10. So now 2 times negative 15 gives me negative 30, and I'm going to list my factors of 30. If you're struggling with listing factors, I'm going to go through this one slowly to kind of give you an idea of how you can make sure you're getting all of them. So start by always dividing by 1. 30 divided by 1 is 30. And then we just go 2. 30 divided by 2 is 15. And then we go 3. 30 divided by 3 is 10. And then we go 4. 30 divided by 4 is a decimal, so I skip it. We're only looking at where we get whole numbered answers. 30 divided by 5, I'm counting up 1, 2, 3, 4 I skipped, 5 is 6. Once you reach the next number that you would use, technically 6 would be next, but I've already reached 6, I know I have all of the factors of the number. So take the number divided by 1, divided by 2, divided by 3, divided by 4, divided by 5. Skip your decimal answers, but keep going until you reach a number that you already have on the other side of your list. That's all your factors. With all that being said, now I have my factors of 30, and I'm trying to figure out which version I can subtract to get a negative 1. So if I subtract 1 and 30, that's going to be 29. 2 and 15, that's going to be 13. 3 and 10, that's going to be 7. But 5 and 6, if I subtract them, I get a 1. The question is, do I want a minus 5 or do I want a minus 6? And because my answer should be a negative 1, I want the larger one to be a negative. So my numbers are positive 5 and negative 6. But now it actually does matter where I put my numbers. I do not want my 5 here. If I put my 5 here, I can't do 2 times the number to get an odd number. If I put my 6 here, I can do my 2 times something to get an even number. But if my 2 had been here, I'd want my 6 here. So you really got to make sure you line stuff up when you're doing these. So I'm going to keep that negative 6x there and that 5x here. When we pull out the number here, it's going to be really easy because we're saying what times x is 5x, and that is just 5. But I do not just pull the negative 6 out here. Sorry, I'm getting like lots of dots. They're kind of bugging me. What I want here then is 2x times what gives me negative 6x, and that would be a negative 3. 2 times negative 3 is negative 6. So when your leading coefficient is 1, these are going to always be the same. But when you have a non-1 up there, these are not always the same. Anyway, I can write my answer now. I'm going to write one term from the side. 2x plus 5 gets its own set of parentheses. And then x minus 3 gets its own set of parentheses. And that is done. I'm going to do this next one a little faster. We're going to start with 4x squared in the top corner and negative 16 in the bottom corner. That's my x squared term in the top, my constant term in the bottom. My x term goes in the middle, but I don't have an x term, so it's 0 x's. We're going to do 4 times negative 16 to give us negative 64. And now I need my factors of 64. 1 and 64, 2 and 32, 3 doesn't work, 4 and 16, 5, 6, 7, 8, and 8. Those are my factors of 64. And remember, I'm trying to subtract to get 0. So 8 minus 8 is 0. I'm going to do an 8x here. I'm going to do a minus 8x here. And now you actually have a couple of options. I know I need x and x. The way to get 4 could either be 4 and 1, or it could be 2 and 2. I'm going to go with 2 and 2 in this case. So I'll say 2 times what gives me negative 8. That's a negative 4. 2 times what gives me positive 8. That's a positive 4. And now I have my factors, 2x minus 4 and 2x plus 4. Letter B, use the zero product property to find the zeros in each equation. So, the whole point of taking general form equations and changing them into factored form is that it's a lot easier to solve a factored form equation than it is to solve a general form equation. The way that we solve it is we're going to take each factor separately, set them equal to 0, and then we're going to solve them independently. So that's 3x minus 5 is 0, and x plus 2 is 0. So solving this is a standard linear equation. Add 5 to both sides, divide by 3 on both sides, and x would be, if we want to go decimal, we could say 1.6 repeating. If you wanted to leave it in fraction form, I'm okay with that too. And the next one couldn't even be easier. Take away 2 on both sides. X is negative 2. That was just a one-stepper. Letter B, we're going to do the whole thing. We are going to take our general form equation and we are going to factor it. And I'm looking for 7. And I want it to be a positive 7, so 10 take away 3 is positive 7. I know I need x and x. The question now is, where should I put the 2? If I put the 2 here, I can't multiply by something to get an odd number. So I need the 2 here. I'm going to just add a little divider guy here so we don't get confused. And the 2 here times a positive 5 here would give me the 10 I need here. X times negative 3 would give me the negative 3x. So I now have 2x minus 3 in one and x plus 5 in the other. But all that we still need to solve. Oops. And I definitely don't have enough space. So maybe you have more, but I'm going to just kind of go on to the next page. So if I would have 2x minus 3 equals 0, I would do a plus 3 on both sides. So that's 2x equals 3. Divide by 2. Divide by 2, and I got x is 1.5. This one's much more straightforward. All we really need to do is a minus 5 on both sides, so I'll just say x equals negative 5. So, that's it. Good luck on the exercises. Please let me know if you have any questions.